Hi, this is Somnath Chatterjee here and my handsome friend Mr. Darcy. Today we will be going over our migration story of migrating from a no-code, easy-to-use ETL tool to the modern data engineering mindset. So the migration was more of a mindset thing than the tool aspects of it. Going over that, in the data engineering world or the data world, the importance of data is based on the insights and the usage of it. Talking on the insights, Brett, is it possible to give an insight of our data world so that they can relate to us a bit more?
Absolutely. Yep, so I'm a software engineer at Cox Automotive, so I'll give a little background about Cox Auto and our reporting and our ETL tool that was supporting our reporting. So Cox Auto is a subsidiary of Cox Enterprises. It's a privately held company headquartered in Atlanta, Georgia. That's where Som and I are from. Cox Auto's mission is to transform the way the world buys, sells, owns, and uses vehicles. Some popular brands that you might recognize are Kelley Blue Book, and Auto Trader. Som and I work for the Manheim business. Manheim is the world's largest wholesale auto auction. It started in 1945. There's 145 auto auctions across North America, Europe, Asia, and Australia. Every year we offer 6 million used vehicles for sale and facilitate transactions over $60 billion in value. So for the presentation today, we'll be talking about our migration from an ETL tool to a modern data engineering mindset, and we'll be going through our road trip through the process. So our starting point, our operational reporting. So I'll give you a little background about what happens at Manheim auctions. So this is a shot of basically like 3 layers of what happens at a Manheim auction. So at the bottom is front office operations. So titles, processing, payments, accounting happen there. The middle is the sale lane bidding, the auction process. So both online and in person, multiple lanes occurring. And then at the top is our vehicle movement and vehicle information processes. So vehicles come in, they get inspected, we capture the information, they get moved around, they get staged for sale, and then at the end they get released. So an idea of some of the scale that we're dealing with, this is a Google Earth image of Manheim, Pennsylvania. This is the world's largest auto auction. This is 600 acres of land, 30 lanes of activity on a sale day. So you can imagine lots of moving parts, people, and we need to avoid misplacing vehicles, and we need to be as efficient as possible in the process. So that's where our reports come in. So our ETL flow was supporting 6 production dashboards containing 25 dashboard tabs. So these are Tableau dashboards. They're highly visible and relied upon for daily operational and decision-making at all the U.S. auctions. So we had 3 Alteryx flows that we needed to migrate. That was our challenge. So this screenshot shows our largest flow. This monolith, it ran every morning at 5 a.m. It could be long running. It required specialized tool knowledge and calculation knowledge to support teammates that come behind us. It would take some time to build up knowledge to start contributing. And the output of this was 2 large denormalized tables that would support Tableau dashboards. I'll hand it off to Som to go through our navigation.
Thank you, Brent. So, our migration story was basically applying the software engineering best practices in the data engineering world. And as of today, how many of you are still using ETL? Yeah, you should be, because ETLs are there, ETLs are good. We are not here to discourage using ETL. We are using ETLs at our end also. So, and how many of us are already invested in some sort of cloud stack databases like Snowflake, Redshift? Most of us, right? Yeah. So you see, if we are still doing the transformations in an ETL tool and we are invested in the cloud stack databases, it's like we have Ferraris and really great cars sitting in the garage to show off, and we are not tapping onto their fun part. So going over some basic principles, like the data engineering world has kept on changing over a long time. We used to work on PL SQL codes, SSRs and all those things. And then the ETL came into the market, the Informatica's, data stage and all those things. And then it was time for databases like Teradata and all, where we again went back to coding, SQLs and stuff, BTEX and all those things. And then it was time for Alteryx and all these easy to use cloud-based tools, and things were getting really, really smooth. But we got easily carried away from the best practices that we actually started with. How many of you would agree with me? Because things became so simple and easy that we were not applying the principles which we had set when we started on these things. But now we are in a world where we can easily focus on the database and data, and we don't have to think on much of the other aspects of where to set the servers and stuff. So we can easily again get back to those same data engineering principles along with what's happening currently in the market. So these are some of the top points which I could think of that we should be covering when we are working in the modern data engineering stack. The data flow architecture, building data pipelines and all. I won't go over one by one in each of them, but if anybody interested on talking on any of the specific points, of course, we can discuss after this call or maybe on LinkedIn or someplace. So moving from ETL to ELT. One interesting thing that happens in ETL to ELT is that we take out the dependency of an external tool where we were doing an extra level of I/O in and out of that tool. And we always had to think about that tool whenever we are increasing our data sets in terms of scalability, in terms of flexibility. We were always blocked with that tool to a certain extent, right? And we had developers based on that, with the skill sets of that tool. So moving away from that tool or doing something extra on top of that tool was always a thing that has to be thought through. So reliability, flexibility, and scalability, I could think of these three as the topmost point that we gain when we move to the ELT world from the ETL world. But there are a lot of other benefits along with that. But you can easily think of these three things as the biggest benefits in that activity. Okay, now let's get to step 0. Step 0 is when we started with the work, it was very important for us to scope out what exactly we are going to do in this migration process. So to scope out, it was a short-term execution, but then it cannot be too short to make it irrelevant over a few months or over a few years. So the long-term vision had to be kept in mind when we planned for the exact scope of work that we are going to do. And that long-term vision was based on what the enterprise architects are planning, what the industry is thinking of in the data world, what the management is thinking, and all those aspects. So you see, the mindset was again to get back in the industry and not just think about one single tool. Okay, so that was the balancing act we had to think through before we started with our step 1. So our step 1 was to start with the end in mind. And here I mean two types of end. One is of course the long-term goal, iteratively where will we be going or hitting in next 1 year or 5 years and all those stuffs. And the other thing was our target data set. So in a migration project, in our case, we would want to stick to that same type of data set that was already there, with maybe minor modifications here and there. So that was the decision, if we should make any change on that one from data architect perspective, the target data set. If we are planning in a long-term plan, if you're thinking of a mesh or a fabric, a data lake or data dump, or if you are thinking of a cloud versus on-premise solution, if you the other aspect was if whatever we are creating, if it's BI accessible, or the way we have been serving the data to our users would be still accessible to them in that new target space, if we plan for a new target space or a new target data set. So that was an important thing. So that was step 1. So once we have finalized, this is how our target data set is supposed to look, and this is where it is supposed to be. Now let's move to step 2. The step 2 was the big E, the extraction part of any ETL or ELT thing. And along with the big E, we had to also think about the small L, the load part. Otherwise, it will become the big L and will keep on haunting us that for a long run. So from the big E perspective, what we had to think through was our source data sets. Where do our source data sets reside today? What's the frequency of the load there? What are the accessibility options if I access it and then load it to the finalized target data set that we have already planned? What's the availability of our source data sets? What the data set volume, changes, complexity, frequency, and all those aspects. So once we have divided all our sources, we can move to the next set. Now see, one interesting aspect in this regard is, when we were in the ETL world, this was a no-brainer because our tool was already doing all these things, right? But in the ELT world, we had to think through all these things. So when we started, it seemed like a big blockage that why should I have to think on this one? But when we started on this activity, it seemed like it's a big flexibility now. Because whenever my ETL job used to run, no matter what the source status is, we had to bring the data at that point of time. But now we can think through if I can load the data in the morning or in the evening or throughout the day, or has it to be real time, and all those things. What the data volume? So based on our source data sets, we can plan for that whole thing. And that gives us a big benefit from the perspective that we can plan for multiple transformations on the same sources in our new space and don't have to redo the whole thing every time. So that was the big E, and of course the small L to keep it small. Next thing was the step. Thus, once we have decided what category our sources falls in, it was time to decide which tool will we be using to do the extraction and the load. And that depended on what kind of stack tools are already available to us, what kind of tools are available in the market for the extraction process. So we can go through the strength and weaknesses of all those, like how easy it is to use both from development and management perspective. How scalable is that extraction and load tool is? What's the cost versus benefit of using it? If there is enough help and support available for that tool or not. So based on that, we categorize some of the tools that, okay, for this kind of sources, we'll be using this tool, and that kind of sources, we'll be using that tool. A basic example would be like if you're on an AWS stack using Glue and DMS, they're the basic stuffs. If we are doing a once a day load or twice a day load, Glue is the way to go. But if you want to do a real-time thing, we can keep a DMS there and keep it going. So it's a big flexibility on that aspect because we already have the tools available to us, but we are not using it to that full extent. So it's time to shift the gears now. Now let's move to step 2, optimizing the data layers. So this is again something which tied us to our long-term vision. So this zoning aspect is something that was decided across Cox, and in our data team, it was planned, like how we are going to plan each of these zones out. So if you see the landing zone, the concept is still the same that we have been using in the ETL world, that previously we used to have a landing zone where we will land in the data and move over it, but then we moved out over time out of that aspect. So landing zone is still the raw data sets that we are getting from the source. Now, after that, in the ELT world, we can curate that a bit more and make it available in the optimized form. So optimized form is still the same data sets in a very basic data format that is available to all the experts in the engineering world, like our data scientists, our data engineers who wants to build something on top of it. It's for those audience. On top of that, we have this refined zone, which is built for all the analysts, our financial analysts, data analysts, technical analysts, business analysts. And the idea of this refined zone is the structure should be very easy to understand. They come here, they see the table structure, they see the data, and they start using it just like that. That's the idea of the refined zone. So we have modified the format of the data now and structured it in a better way. On top of that, we have this confirmed zone, which is for our specific business or measurements or matrices, which is very specific to some group of businesses. Like if I talk about sale may mean a different thing to the finance team and may mean a different thing to the account team, may mean different thing to the inventory team. So in that aspect, we have to think through. So the confirmed zone is very domain specific for a specific group of user. That's where the audience comes into picture. And these things are very, like it's like differentiating the based on consent in the architect world. That's how these things were designed. And DBT actually helped us go through each of those processes and pushed us on that aspect. Now, this was what we gained out of it. Now, as I was showing you the step to our zoning concept, this is what we gained. On the left, if you see what we had before, our old data flow. So we had this ETL tool, which was very easy to use. We would be loading all the data in this ETL tool. Every time we run it, do all the computations, all the stuffs in this ETL tool itself, and then push out the final data set. And we were happy with that. It was running very fine. It used to take like 3 hours. And it was loading so much of data and doing so much of computation that we felt like, man, this is amazing. And this is highly visible. As Brett was showing you that how visible it is and people are using it at auctions. We are quite happy with that. In the new pattern, now we have the landing zone, the optimized zones, the refined zones, and on top of we have confirmed zone also here, which is not shown in the diagram, but we have the confirmed zone also here. So now we can cater to a lot of users compared to the kind of users we are catering before. Otherwise, in the prior world, all of our users were actually coming to the same target table set which we had. And the problem with that was whenever our business would ask for some more or extra metrics and we are adding it there, it's hurting everybody. So now we don't have to do all those things because anybody who is more technical, they can just go to the refined zone. Anybody wanting to go for the raw data set and all those stuffs, we are already curating the data for them in the optimized zone. So that they don't have to curate the data by themselves, but they have some data set available to them. So now let's move to step 3, under the hood. So under the hood is more like tuning the engine. How about I share some of our learnings and experiences as we started looking under the hood. So it's like all of us in the modern day knows how to tune a car by just looking at a DIY video on YouTube, and then we get dirty when we start trying that on a new car, right? But interestingly, in this tune-up, we are already aware of our engine, because the engine or the magic is not DBT. The engine or the magic is the database that we were already using, and we have been learning about it. Like if you are using Snowflake, I'm sure you have read a lot about Snowflake, what Snowflake does, how Snowflake works, and that. If you're using Redshift or whatever database you might be using, you have studied a lot on that database. So you are already aware of your engine. And that's how we had to think when we planned our transformation. Not based on how DBT works, but based on how that database exactly works. So based on that, we can have our sort keys, dimension keys, indexes, the partitions in case of Snowflake, the other stuffs, how you plan that thing out. So now, if you see the first block, now these kind of things are very easy to do in a ETL world. Like we take 2 data streams, and that's why I said it was a mindset migration, because in the ETL world, a lot of things are quite easy to do, and when we think from a staging perspective that we have to stage the data at every end, it seems a big deal, but it is not. So I'll go over that. So it's not a as-is shift. So we had to redo the whole logic of how the data had to be transformed. In the ETL world, it's very easy to take 2 data streams and keep on joining them based on different join criteria. Now, if you try to do that in the query itself, now you see how much computation you're using because you keep on doing the self-join again and again on the same data set, right? So the way we handled it, and it's working amazing, is by adding a relation table or a link table in the data vault architecture. If you see or go through the data vault architecture, we can discuss about it if anyone wants to know. If you have a link table there and the link table holds the key values for the join and the descriptions, it performed amazingly in doing all these things, like doing the multiple joins on the same data streams. Now, another thing was having all these aggregations, having all these filters, any computation that was based on a single column or a single source, we tried to move them as much as possible towards the source. Like as we started, let's get them done so that our data sets become as thin as possible. Because in our case, we are working with a columnar database like Snowflake or Redshift. So we want to make it as thin as possible so that we can deal with less number of columns. And they perform amazing, no matter how much data you have. So, and then if we have some derivations where there are multiple derivations based on a single column or a single source, try to move them as far as possible towards the target. So we can again make it wider or denormalize at the end itself. So basically the idea is going wide for any event kind of data and going narrow for any kind of aggregations or computed information that we are deriving. So those were our principles. You can figure out your stuffs, what your database needs are. But those are some rule of thumbs that we applied when we were doing these transformations. So arriving at the destination, Brett, is it possible to, so I talked about our databases, data engineering world, what we did and also, how did DBT helped us and did we really gain anything out of it?
Absolutely, talk about it. So arriving at the destination. So Soma team did an amazing job analyzing and breaking down our big, giant monolith Alteryx flow into the constituent parts. So now it's time to bring that to life with the help of DBT. And at the end of it all, hook up our Tableau dashboards and not disturb anything. So this screenshot shows our final DAG of our large Alteryx migration. So the great thing that we discovered about DBT is that the DAG moves with us as we build. So we can quickly see relationships and data lineage as we make progress. For our migration, we used AWS Redshift database with the private link to DBT Cloud as our IDE. So to create this DAG, we used the common approach in building in DBT combined with SOM's enhanced zoning approach. So on the left side, of course, we create our data source domains with our YAML files. A lot of our source data was already in Redshift, and then we had some in S3, and DBT makes it really easy to consume S3 data with external tables functionality. From there, we built our staging zone. So this is our raw source data, no transformations yet, just views and materialized views of that raw data. Then our optimized zone, Som talked about this. So this is our less noisy but still close to raw data. This can be used by data science and machine learning teams. Then our refined zone. This is the workhorse zone of the project. The SQL models here integrate data from multiple data sources and combine at a common grain and add aggregations. So like Som said, data analysts can explore this area. Finally is the conform zone. The SQL models here create the semantic tables by joining multiple refined zone tables and adding business logic. These tables are highly denormalized, easily consumed by Tableau dashboards and other reporting tools that can slice and dice through those big tables. Business users and ad hoc users can benefit by using this uniform, combined, and holistic data. And then, of course, on the far right is our exposures. So our Tableau hyperfiles, as well as the Tableau dashboards themselves. So with this whole zone modular design, we get the benefits to the whole organization because they can query any one of these models. All right, so some of the benefits that we realized by embracing DBT. Visibility, that's our biggest one, visibility. DBT Cloud has the documentation area called Explore, I think most are familiar with. Our code and our DAGs are visible to end users with read access. And then our SQL is available there as well as GitHub for the whole enterprise to see. So we're building data trust here. Then we get CI/CD, so continuous integration and delivery. So we're bringing proper software engineering practices to data engineering with DBT's integrations. We get branches, pull requests, code reviews, approvals, versioning, deployments, and rollbacks. We get readability because the code is SQL. No proprietary tool calculation or knowledge needed. Easy for teammates to come in and make contributions. Of course, we're pushing the processing down to the database, reducing our runtime and volume on our network. It's portable, of course, so we can bring that code to any data cloud that we want. So digging in a little further on our exposures, we added data quality tests you can see here to our sources to ensure uniqueness and not nulls on our primary keys. Then we added source freshness to warn about stale source data. And warnings here showed us that one of our sources was coming in later than our cron schedule. And because of that, we were quickly able to adjust our schedule and get all of our data in a timely manner. We were able to set up webhook error notification emails. So these emails would go out to our development team as well as our support team. And with these, support was quickly able to take action and rerun our jobs. Especially nice is the rerun from a failure point, saving time so they don't have to rerun the entire flow from start. Another benefit that we got is DBT recommendations. So DBT gave us recommendations to help us get to a proper data engineering design. You can see a primary key test is recommended here, as well as a undocumented model that we need to pick up, so eliminate some future tech debt. So at the end of it all, we hooked up our Tableau dashboards. We tested a lot. We deployed a soft deploy, and then when we were ready, we flipped over to a full deployment, and we saved 90% of our runtime of our flow. So we went from 3 hours to 15 minutes with the help of DBT. So DBT helped us transform into a modern data engineering mindset and process flow. So this is Somnath and I's LinkedIn, so feel free to reach out. But thank you for joining us.